We're going to start off with a quick review of what we just did just before the Christmas holidays, and I want to talk about right-hand rules number 1, right-hand rules number 2. In other words, right-hand rule number 1 for a straight conductor, and then we're going to take a look at right-hand rule number 2 for coils, or another fancy word for coils is just a solenoid. All right? So to start off with, I want you to focus right off the bat on this diagram over here. Of course, what you're looking at is nothing more than a piece of wire. And right now what you're going to see here is the red arrow showing the direction of conventional current flow. Keep in mind, conventional current flow is, of course, the flow of positive charge as opposed to negatively charged electrons. So we have positive conventional current flowing through the wire in the direction of the arrow. Keep in mind, if you take a look at the cross-section of the wire itself, you may notice that there's a circular cross-section, and if current is going towards that circular cross-section, we can actually place a little red dot, or just a circular dot, to show the direction in which the current is, of course, going. Now, by using right-hand rule number 1, what we're going to do is we're going to wrap our right hand around this wire. Okay, so if you can take your right hand, imagine that you're wrapping your right hand around this piece of wire so that your thumb is pointing in the direction of current flow. Now, if you do this properly, your hands should actually wrap around this wire so that the magnetic field that is induced around the wire will actually go in this particular direction. Okay? And as you can see, from the diagram itself, you can see that the magnetic field is actually going in somewhat of a counterclockwise direction around that wire. Okay? And that's how we use right-hand rule number 1. To give you another example, what we'll do is we'll take a look at the second diagram over here. Now, this time, what we're going to do is we're going to take a look at just the cross-sectional piece of the wire itself. So if you look at the cross-sectional, this diagram over here, if you look at the cross-section of the wire, once again, you can see that current is actually flowing towards you. So if the current is flowing towards you, I want you to wrap your hand around this wire so that your thumb is pointing directly towards you. And if you wrap your fingers around that wire, you'll actually notice that once again, the magnetic field that you've just induced is again flowing in a counterclockwise direction. Okay? On the contrary, if you take a look at this diagram over here, okay, you'll notice that there's an X in the middle of that cross-sectional piece of wire. So the X basically denotes that the current is actually traveling away from you, and in this case, towards the screen. So if current is going away from you, once again, what you're going to do is you're going to wrap your right hand around the wire so that your thumb is actually pointing away from you. I know that's a little bit difficult to do, but I want you to try that. And if you wrap your fingers around that wire, you'll actually notice that this way. You'll notice that the magnetic field lines actually go this time in a clockwise direction. Okay? And again, we're going to leave it at that for now for right-hand rule number 1. Now, what we're going to do is we're going to take that straight piece of wire, and what we're going to do is we're going to imagine that we've taken that wire and we've wrapped it around into somewhat of a loop, or in this case, several loops. If you take a look at this diagram over here, again, I'm looking at this diagram over here, you'll notice that I've now taken that same straight piece of wire, it's attached to a battery source, and you'll notice that, of course, in this case, we've wrapped it in a coil, okay? And that coil is actually wrapped around some type of a ferromagnetic material, in this case, most likely iron. Now, before I continue with this, always keep in mind that you should try and label the positive and negative terminals of the battery. If you take a look at the battery itself, you'll always see that the longer line represents the positive terminal, the shorter line, the negative terminal. Once again, we're talking about conventional current flow. Whenever we're talking about conventional current flow, we know that current is going to flow from the positive terminal towards the negative terminal. So if you follow the direction of current flow, you'll actually notice that current flows in this direction. And if you were to follow the current through the coil, it goes through the wire in this particular direction. Now, here's what we're going to do. This time for right hand rule number 2, what you're going to do is you're going to take your right hand and you're going to wrap your right hand around the coil so that this time your fingers are going in the direction of current flow through the coil. So if you wrap your fingers around the coil so that your fingers go in the same direction of the current flowing through the coil, you'll notice that your thumb actually points up here. I'm going to put a letter N there to represent where your thumb points. The opposite end of your thumb, which is of course the butt of your hand, will of course now represent the south end. Okay. Now, in essence, what you've just created is a simple electromagnet. All right. Now, of course, your thumb always points to what happens to be the north end of the electromagnet. The butt of the hand is going to be the south end. If you can imagine that coil as being hollow, it turns out that there is, in fact, a magnetic field that you have just induced through that coil. And the direction of that magnetic field goes in the same direction as your thumb. Okay? And that, in essence, is right-hand rule number 2. Let's do another example over here. In this diagram, again, I'm looking at this diagram over here. Once again, what I'll do is I'll start off by labeling the positive and negative terminals of the battery. And I'm going to show you the direction in which the current is flowing from the positive to the negative terminal. If I follow the direction of current from positive to the negative terminal, you'll notice that current flows in the direction shown by the red arrows. Okay? Now, once again, what you're going to do is you're going to take your right hand and you're going to wrap your right hand around the coil so that it's going in the same direction as the current flowing through the coils. So if you wrap your right hand around that coil, you'll notice that your thumb points to north, and the opposite end of your thumb, the butt of your hand, is south. And if you can imagine a magnetic field that exists between that coil, the magnetic field always goes in the direction in which your thumb is pointing as well. Okay? And that, in essence, is right-hand rule number 2. For the next lesson, what we're going to do is we're going to start talking about the motor principle, and this is where I introduce to you what's often referred to as right-hand rule number 3, or sometimes it's referred to as the right-hand palm rule. Okay? That's it for right now, and we'll see you very shortly.